everybody. How is everybody doing today? It is a very, very bright, very, very cold Thursday. So happy it's Thursday today. And I wanted to talk to you guys about a little project that my kids and I had this weekend. We talked the other day about music and science. Oh, and I also talked about being discrete. And yeah, discrete, I had it right. Disparate objects. Anyway, little science project the other day, and I wanted to tell you guys about that. And then there's some of the other ones we tried before, but this one was a good one. So I mentioned the other day about music and camp and science and trying to get kids to learn a little bit of everything. And obviously one of the kid pastimes is to take crayons and draw pictures. That's a lot of fun. Science is a little bit harder to make fun, but it's still can be fun. I mean, they don't mind watching shows like Bill Nye, or we actually watched Mr. Wizard. Veritasium is a great YouTube channel. I'd recommend Veritasium highly. Try and get them interested in science and mathematics as well. I'm going to turn that down. I had my heat up all the way, and that was probably making a bit of noise. Foolish. So, long story short, because I'm really on crazy tangents this morning, we decided we were going to test the strength of some string. We took some very, very thin thread, jerry-rigged this thing up in the air that we could tie it to, and then tied the other end of it to a bucket. So the bucket was a couple inches off the floor. And then we put building blocks. We have these building blocks where a lot of the blocks are the same identical pieces. And so we'd put these building blocks in until the string would break. And we did that probably about a dozen times. And each time we got a slightly different answer. So the first part of the experiment is, what do you think is causing all these different fluctuations in our results? Why is it that one time it takes 18 and another time it takes 30 and then it's 23 and 25? And then I showed them how they can take that and get an average. So on the average, and here's your bell curve, typically it would be something like 23 blocks. And then we ran out of that shape of block. Well, I'm getting ahead of myself. Then we decided, and this was the real heart of the experiment, is, can we accurately predict how much weight it's going to take to break two strings? Now my thought was, how much is it going to take to break 3 strings, 4 strings, 5 strings? We do the whole thing. The problem is that the string was a lot stronger than I thought. It took a lot more to break one string than I expected. And it took so much to break 2 strings that there was no room left in the bucket. We were running out of blocks. So, at first it was just a matter of how many blocks is it going to take to break. But then we ran out of that identical shaped block, and we had to use different shapes of blocks. But that doesn't add up. Now you're doing apples and oranges. So we've got to break it all down to the lowest common denominator, which would be, in this case, weight. And so we took a scale, we had a little food scale, and we weighed each block, figured out how much weight it took to break 2 strings. So we all made our prediction as to how many blocks it would take to break 2 strings. We ran out of blocks, had to put more and more in, different shapes. So we took our prediction, converted that to weight, took the blocks, converted that to weight. And then we decided how accurate each of our predictions was. And some of our predictions were extraordinarily accurate, because somebody had decided that it would probably be slightly more than it would take to break 2 strings. 1 string. I'm talking all over my words today. That it would take slightly more weight than double what it takes to break 1 string. And that's what it wound up actually being. But I showed them how to take all that data and put it in charts. And that was the least interesting thing to them. I thought it was fascinating. How you could take an Excel spreadsheet, pump in all the data, and it'll automatically calculate for you the weight for each particular run. But we like to do things like that. We've done experiments where we take some plastic wrap, stretch it over a bowl, take a bunch of little pieces of paper, stick them on top of the plastic wrap, and then put that bowl next to a stereo and play different music to watch the way that they bounce. So you can see the sound waves. Even though you don't see anything actually touching, the sound waves are affecting the membrane. One of my favorites is take a string and draw it from one end of the house to the other in a straight line. And then put a straw on the string and then tie a balloon to the straw. So normally when you take a balloon and you blow it up and you let it go, it just flies all over the place. But if you can focus that energy and give it a little direction, just a little bit, it'll create something useful. You can take an object and move it from point A to point B. You could even make like a little Lego figurine of some kind that would be attached to the straw. So when you put the string on there, the Lego figurine can accelerate from point A to point B. You can see how dangerous that might be if not properly secured. So I like to do experiments like that. You know, you guys got any ideas? I read books of all kinds of stuff like that, and a lot of times it kind of turns out, but the how much weight will this string break one was one of the best ones we've done, because it worked out well. Everybody totally understood it, and that was a good way to teach actual scientific progress. Process. We're actually testing something real and legitimate that we can have legitimate results on, not just a, hey, look, the paper's green now. Oh, I wonder why that is. Because you put it in a goopy stuff, bowl of goopy green stuff. It's going to turn green. That's kind of obvious. But what do you guys think? You know, you guys got some experiments. Are there any other resources that you like to teach your kids about, that kind of stuff? Let me know. I'm interested. And have a nice day.